Thanks, Jessica. Hi, everybody. So as I'm going to kick things off, I'm going to make sure that you guys are slowing your aging from the get-go. So I want everyone to stand up. Put your booklets down. I want you to relax, shake your shoulders. That's it. Now put your hands in the air. Now wave them around like you just don't care. Now clap. Clap, 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 clap. Faster, faster, faster. Come on, you can do this. Faster, faster, faster. Come on, let's get some energy in the room. Come on. Thank you so much. Wow, I don't get standing ovation normally before I've started, but that's a really good start. Thanks, guys. Hopefully you're all feeling a little bit more awakened. Hi, guys. I'm Pete Ward. I'm the co-founder and CEO of Humanity. And I'm going to be giving you guys a sense of why this is the way to disrupt health completely and how it can validate what intervention, any health intervention, is working and more importantly, who it's working for, i.e. you or someone else. So it's very simple focus. Anything we do is about how you can slow or reverse aging. And my background, I'm a consumer tech founder, so I literally have been working doing travel social networks, and my co-founder of dating sites. And our mission is quite bold. We want to essentially give 1 billion years of health back to humanity. Now this is a measure, our North Star measure, which we think all pharmaceutical companies, all health companies should be using as their yardstick or benchmark for whether what they are bringing to the market is working. I.e. not if it lowers your blood pressure, but if it increases your health span or gives you extra years of health, even if it's 0.25 years of health or however long it is, that's how everything should be measured against, and it should be measured against for that person. So as I mentioned, my background and my co-founder Mike's background is in consumer tech. We're not from the health industry, and a lot of the creative disruption happens in startup world where you see an Uber come along and disrupt, the minicab industry. Is not someone who was a really good minicab driver. It's someone who knows how to build a completely different way of doing things to change the way things are being done. And so Badoo is a company that my co-founder was on the founding team of. That became the world's largest dating site and now powers Bumble. It sold for $3 billion to Blackstone Group. And I created one of the world's largest travel social networks. And Mike also was on the running operations for what became the largest consumer VPN in the world, which got to 900 million users. So in other words, we know how to get to 1 billion users in whatever we do. We know how to engage them, and we know how to change their behavior. So why is aging the problem? Why should we be focusing on aging and not on curing cancer or Alzheimer's or any of the other end-stage diseases that many of us, who are in the health industry are thinking that's what I want to make a difference in? Well, if we were to cure cancer, we estimate we're only going to give us an extra 4 years of extra health span. And if we also cured cardiovascular disease, maybe another year. Whereas if you were to slow the aging process, and that means essentially keeping our bodies and minds fully functional for as long as possible, well, then we can extend our health span and lifespan by at least 20 years. And this is a big problem for the societies of the world and the health systems because they can't sustain the costs. The costs go up, and the incidences go up as you age. So you'll notice that there's not surprisingly a huge exponential growth in incidence and costs as we age. Something happens in our 40s and 50s, and then particularly in our 60s and 70s, where these things, become a problem. And if you look at actually what is the biggest cause of cancer, biggest cause of Alzheimer's, and so on, by far the biggest single thing is aging. And just to be clear on what we're focused on here, we're not talking about you getting sick and then keeping you alive on a machine or, unwell for 20, 30, 40 years. We're talking about extending the healthy years of health, the years where you are not even having any kind of non-communicable or infectious disease. And so this is the solution that we've come up with. It's as simple as possible, so yourself, your mum, and your dad, your kids could work out how to use it. And it provides you with a feedback loop to know whether what you're doing is working. And it does two things. As Jessica mentioned, number one, it monitors your rate of aging and biological age, i.e. your physiological and actual health age as opposed to your chronological actual age. And it helps you slow it down. It guides you to slow it down like a Waze does for traffic. And so this distillation of product is what makes the thing work, because you start with this feedback loop. This, what am I trying to achieve? Well, everyone wants to slow their aging. Everyone wants to have a lower biological age. And that's updated every day, validated against longitudinal data sets from the UK Biobank, from NHANES, CDC in the US. So real world outcomes, people who got sick and died, and they were monitored with heart rate sensors and accelerometers 15, 20 years ago, so you could see what their movement and heart rate patterns were 15, 20 years ago. Fast forward to now, you can see who got sick and who died. And we compare your movement and heart rate patterns every single day to those hundreds of thousands of participants from those data banks. The second thing, and the heart of the app, is guidance. So I mentioned Waze, the traffic app. So very similarly, like Waze, it knows where you are on your journey, and based on other people who took a similar journey before you, it can guide you to the most optimal route that will take you there in the least amount of time. In 17 minutes, take the second right instead of the first right. And that's because every single person who's driving or is checking in to work out where to get to is in a completely different place. And there are different days and different moments where things are happening differently. And that is the same as our health. Every clinical trial, every meta-study will tell you that for some group it works and some group it doesn't. And it never tells you which one it does work for, which one it doesn't. And that's because everyone's different. And then lastly, it gamifies it with a daily score, which is a function of your movement, your nutrition, your mind and recovery actions, so that at any given point you can see how you're doing and you are given reward for the actions that are most likely to be impactful and you're most likely to do. And here's the thing, it's already working. We have already done the statistical analysis to a 95% confidence interval where we can see the impact of every action that's being monitored on our platform and what impact those actions have on your health span. In other words, how much will an extra 10 minutes of high-intensity interval training have on your health span if you keep doing that? How much will an extra hour of sleep, or if you do some meditation, or if you reduce the number of snacks? All these things can be monitored and compared to other people who are doing similar things to you. And of course, based on your own phenotype and age, behavior, and so on. And of course, the more users you get, the more predictive it becomes, and therefore more personalized, and the circle goes on. And so to give you an idea, this is just a snapshot of the differences that we're seeing if you break it down by gender, or by age, or by weight. And already you're seeing massive differences. The fact that the bars are not, equalized is telling you that for different groups of people, it's working differently. And this is just the start, because then you can get right down to the level of personalization and predictability where you are essentially comparing yourself to your digital twins, based on your gene attributes, based on your methylation, based on your combinatorial blood markers, as well as digital markers, as well as your age, as well as your activity. All these things, which are multivariants, will be your base, and then it's what incremental effect any additional activity you do will have on that base. We can't make this work if we can't change behavior, the holy grail of any kind of health intervention. And any doctor will tell you, well, we can't get you to do this because you won't do it, so we'll give you a pill instead. Well, that's just not true. You just need to know how to do it, and you need to give a reason for people for why to do it. And the funny thing is, the why is pretty strong once you make people realize what it is they actually want. Because there's only two things that people want when it comes to their health. What is it that I should do to be healthier? And secondly, is it working? We all have tried our 10,000 steps and we think, great, we hit our 10,000 steps, but has that made me healthier? Who knows? I feel good. It's an abstraction. And we need to know how all these things that we're doing has an effect on our actual health. And this translates into actual numbers of years of health. So as I mentioned, our mission is to get 1 billion years of health. We've already actually yielded over 30,000 years, and I can't sort of officially publish it, but I think we're actually over 50,000 now on the last analysis. And that means that we are giving health back to people so they can spend more time with their loved ones. And there was a study that was done recently where they actually calculated the economic and societal impact of giving a year of health back to humanity. And it was a guy called David Sinclair, who's a longevity scientist at Harvard Medical School, a guy called Andrew J. Scott, who's a chief economist at London Business School, and also a geneticist at University of Oxford called Martin Ellison. And they calculated that if we were to give a year of health back to society, that would be worth $38 trillion to the global economy. So if I break that down to you based on our 8 billion population, assuming everyone is equal, that's $47,000 of economic value per year of health per person. So we've already generated over 1 billion years of health of impact. If we hit our mission of 1 billion years, we'll have had 47 trillion. And that's essentially what we're here to do. That's why we are talking to you guys. We want to raise all ships and be open and collaborative and basically work together with pharmaceutical companies, with health intervention providers and the industry to essentially create the new yardstick of health, which is years of health, not whether we can lower your blood pressure, not whether we can get a couple of inches off of your cholesterol, but actually can we give you more years of health span. Thank you very much.
Thank you, Peter. So I don't know about anybody else. It might just be the 4 shots of coffee that I've had this morning, or it could be the waving our hands in the air and clapping, but I'm starting to feel that my aging is slowing already. So I've got a couple of questions to kick us off, and then I'm going to open it up to the rest of the room. But I think what you're saying there about how we approach aging is incredibly interesting. And we were at an event last night where we were also talking about the role of technology in care of older people. And actually, traditionally, we look at a very disease-specific approach. And so actually, is it better to look at aging more broadly, because actually that is the challenge. And we're here on the Digital Pharma stage, and pharma often approaches disease-specific challenges in a therapy-specific approach. So I'm really keen to understand from you, how can pharma shift to look more broadly at aging rather than disease-specific targeted approaches? Or is it both in parallel? Like, what can we do there, and how can we use that data to make people's health better for longer?
Thanks, Jessica. So one of the challenges, particularly in the US, is whether the FDA will recognize aging as a disease, because for obvious reasons, you don't want people to feel stigmatized by getting older. But actually, if you look at what people are working on in a lot of the pharmaceutical companies in the US, particularly the big well-funded biotech startups, a lot of them are working on the aging process and the precursors to what leads to cancer, cardiovascular disease, and so on. So whilst they may get their funding from different organizations and from the departments for cancer, they're actually looking at the process that leads to increasing risk of cancer. So for example, one of the companies who the founder and CEO is on our scientific advisory board, her name is Kristen Fortney. She's just literally made an announcement, which is pretty much a breakthrough last night, that they have done human trials, not animal trials, but human trials on people to see whether they can give them a drug that will reverse muscle atrophy, which you can imagine is a huge problem, particularly when you get older and you become more frail and you have high risk of falling. And they have essentially shown, first in mice, now in humans, that they can reverse muscle atrophy and give you, more functionality in your musculoskeletal system as a result of taking a drug. They are an Andreessen Horowitz-backed company. They've raised over $40-50 million, and they are targeting age-related diseases, but they are picking certain use cases, in this case muscle atrophy, to sort of look at one of the systems that can affect aging, and they're doing really well.
Amazing, thank you. All right, well, the second question I had was about data. We live in a very data-driven world, and I think, you're working with B2C solution, but collecting a huge amount of data, and we've seen the sheer volume of data points that you're collecting. But I'm really interested to understand, how can we utilize that really rich source of data that you and many other innovators like you are collecting to really improve healthcare at population level and on a huge, huge scale?
Yes, it's a great question. This is actually one of the most interesting things for me coming into this field, having not been in health. If you talk to people in the health industry, often they want you to speak to a health expert. So I end up getting connected to a medical doctor or a surgeon who now is in business, and they're trying to assess how good our solution is, for example. And the funny thing is, it's a completely different science. Data science and how to understand biology are two fundamental different things. And this is a massive challenge to the status quo, because data science, as we've seen with Google's program, AlphaFold, which is essentially able to predict the protein folding. I mean, there's no doctor that can do that by their expertise. This is a data science problem using machine learning and AI. And you might have all seen recently how everyone can change the way they look based on AI photos. It's going viral, called Lensa.ai. I mean, AI is changing the world. It is disrupting everyone and everything, such that the jobs we know and do today will be completely gone. And so I think people need to embrace data science, and data science is changing the way that we look at health, and we are doing the same. So in our case, we pull in all of the data from Apple Health, soon to be Health Connect and Google Fit. We have billions of health data points already from all of the stuff that you guys have been doing for years and months, depending on how long you've had a smartphone or how long you've had a wearable. And we're essentially looking at those patterns and signals in every single one of those data points, whether it be your heart rate variability, whether it be your menstrual cycles, whether it be your blood oxygen levels, your sleep patterns. And you can just start running the regressions on that and comparing it to real-world outcome data from biobanks. We will become our own biobank, and we want to open that up in a privacy-preserving way, create synthetic data sets so that you can actually train other people's models, your models, onto other breakthroughs in other areas that we're not focused on. The data is really the key, because it unlocks all of the learnings and insights that none of us will ever be able to do through clinical trials. And it's already been shown in observational studies, real-world evidence studies, that a lot of the things that we thought to be true in nutrition, for example, are no longer true. And there's such a confusion in this, because is it good for you, is it not good for you? And it's data science is the way that we're going to solve that problem. Not because we're going to run another trial to see whether vitamin D is good or not, which they've done hundreds of, and they've essentially concluded it doesn't really have any effect. Sorry, everyone who's taking vitamin D.
Fantastic. All right. I think that's enough from me, but I'm really keen to open it up to all of you. So are there any questions in the audience? Anyone got anything burning that they want to ask Peter about aging, about data? All right. Keep your hands in the air so I can see you. Catherine, I'll come to you first. Say your name and where you're from.
Hi, I'm Catherine. I'm a medical content advisor and GP. I really enjoyed your talk, but I'm really interested to essentially hear how you're going to make aging sexy, for want of a better word, for the younger population. Presumably, aging journeys start from when we're born. How are you getting younger users engaged using your product going forward?
Okay, I guess they want me to have a mic. So it's a very good question. I mean, we do, in our sort of retention and engagement data, we find that it's off the roof across the board. So we have, for those who subscribe, it's 65% retention after 3 months, which is like nearly WhatsApp levels. And 65% are using it at least once a week, 35% at least once a day. We do see a slight drop-off in every decade of age. So the over 60s are more active than the over 50s, than the over 40s, than the over 30s, although there's a nice increase after you hit 30-something for some reason. We all start to become aware about aging. I think that the funny thing we're finding in our data is that there is a shift in consciousness and awareness amongst the Gen Zers and the Gen Y, where people are becoming a lot more conscious of their health, and they are already taking actions in their teens, in their early 20s, to start, essentially avoiding the risks that we all face in our middle to later ages. So I think there is a shift in aging becoming less of a taboo and more of a topical area. And it's actually a bit of a zeitgeist in longevity movements now. So if you look at the biohacking community, longevity is the buzzword. So whether the word is longevity, lifespan, health span. It's less. Funny enough, aging is like the get your attention, but actually, in some respects, the focus is extending years of giving life to people. Really, everyone wants a bit of life, whether you want to live a lot of life or a high quality life or a lot of years of life. I think that's the thing we can galvanize everybody around. And so part of our goal, and the reason we called ourselves Humanity, is we don't just want you to help yourself get years of life. We want you to help your family and friends and all humanity by contributing to this problem. And the more open and collaborative we can be in the data learnings, like any system, the more personalized, more predictive, the more accurate it will be for everybody. So I think we just need to, lead the charge in showing people why this is going to help save humanity from itself.
Thank you, Peter. All right, next question, please. Raise your hands. I'll come over here. What's your name and where are you from?
Okay. Hello, I'm Faust. I'm studying biomedical science. And my question is more related with your data again. Thank you for your speech. You know that in other countries, like aging is different because of the Mediterranean diet, of environment, of the stress. So how you're taking this in consideration when you're collecting your data? And are you working maybe with the UK and USA data when creating this app?
Yeah, absolutely. I think the beauty of, and this is available to anybody, by the way, there are biobanks pretty much in every country. So it's the Estonian biobank has 200,000 participants and incredible data sets. You have a bunch in the US like NHANES and various others. There's one in New Zealand. There's obviously the UK biobank. So these biobanks are capturing more and more of this data, but there are gaps. And that's why we want to fill one of those gaps in building our own global biobank for preventative health, which will include information like what people are eating, when they're eating, how many snacks they're having, and so on. There are other researchers doing this. So there's a company, friends of ours, Zoe. You might have heard of Tim Spector, who's out of King's College London. Him and Jonathan and George have co-founded a great company called Zoe, where they're looking very much on the nutritional science side of things. And they launched the COVID app that some of you might be familiar with. And they learned a ton from doing that through observational studies. And so, yes, the Mediterranean diet is a great example where it's often cited as the healthiest diet, whereas Tim would say himself that based on his study of poop from many of the participants in his recent Zoe Predict study, he was saying it's actually less about whether you have that diet or this diet. It's about the variety of plant species that you have in your diet. So in other words, he recommends 30 or more plant species per week, which includes things like seeds and other forms of plant. And that's more important. And of course, those who are on a plant-based diet or a Mediterranean diet typically are having whole foods, not processed or ultra-processed foods. And so his data is validating that. But he also makes a massive caveat that he shows that everyone is different and it affects everyone slightly differently. So whilst there's a general guidance that could say follow Mediterranean because the blue zones and there's many in the Mediterranean part of the world will say whole food. We all know whole foods are good. We all know these things are good. We don't know the degree to which you or I need selenium in our diet or whether we need to have more zinc or more of that. And I think that's the point. We need to monitor ourselves. We need to then understand whether if we change something in what we're doing, whether it has a positive or negative effect. And yes, we should be using the general studies we have to date to have our starting point. We then need to validate to see whether it's working for us.
Brilliant, thank you. All right, we've got time for one more question. Gurpreet, I'm going to come to you.
Hi, I'm Dr. Gurpreet Singh. I'm a GP and a Chief Health Science Officer at Fitfile, which is a health data technology company. Very specifically, I guess, thinking about the amount of data that you're collecting and trying to do research in a privacy-enhancing, privacy-preserving manner, are there any additional data sets that you think would be, if combined with the data you've collected, would enhance and add significant value? And if so, what are they that you think are really relative to longevity?
I mean, 100%. I mean, obviously, it depends what you're optimizing for. From an aging perspective overall, then I think as many of the biomarkers on what we're measuring from wearables and so on is one thing. So if you have Aura, for example, will have more precise data on sleep patterns, so that will be a useful integration with our data. Whilst we pick some of it from Apple Health, we don't get all of it. In these biobanks, we do have whole genome sequencing data and SNPs. We do have DNA methylation data in some data samples. It's quite scarce. So to some extent, we hope to get a bunch of that ourselves by offering it, as an upgrade solution to our users. But I think there is so much crossover in so many areas. If you're talking like Grail in the US, they are looking at the sequencing of tumors and comparing that to non-tumor-based sequences so they can detect cancer. So I think whether it be through blood or saliva, I think from digital, it's going to be hard to get everything. Digital gives you a good portion of it. So if you talk it in statistical terms, there's something called concordance. Concordance from predictors to outcomes. And the concordance of, say, digital markers is around 62-63%, which is similar to getting a blood panel. But you really want to get that concordance up to like 95-99% ideally, and that requires you having more data. And so if you add bloods, if you add DNA methylation data, if you add all these other population data sets, then that concordance will just go higher and higher. And so I think, as much data you can on any health, like electronic health records, obviously is key. Any kind of data sets on what people have done and what effect it's had over time is valuable.
Fantastic. Thank you so much, Peter. This has been incredibly interesting, and I am definitely going to be checking out Humanity and seeing what I can do to slow down my aging.